Here we have to determine the wavelength of the given laser source. The method that we use is the diffraction. What is diffraction is nothing but it's a bending of light around the corner of obstacle. Here we take a diffraction grating which is placed in front of the laser source, and we can see the graph in front of that where we are getting the maximum and minimum fringes alternates. Here you see the maximum, central maxima. After that you move other sides, the intensity of the those dots are decreasing continuously. So we have to take the distance first as 80 centimeter from the laser grating to this graph as 80 centimeter. After that you take a pencil and you mark the central maxima. You take the central maxima, and taking that as a central point, you mark the 5 points next to the central maxima and 5 points to the right. Both the sides you mark 5 points. After that you switch it off. Now taking out this graph sheet, you take a scale. You take a scale, and using scale you note down these readings. Here you note down these readings. These readings will give you nothing but the 2xn value, what we have in the formula. With the help of these 2xn values, you can calculate the lambda value that is supposed to be find out. Now using a scale you find out this thing. What is 2xn value over here? It's given here around 2.5 centimeters. For this thing around 5 centimeters. Now here in the procedure, as you can see here, you can find out the 2xn values. After that finding, you can find out divide by 2 and you can find out xn. After finding xn, you can find out the theta n. Theta n is nothing but tan inverse of xn divided by f. Here f is nothing but the distance, which is 80 centimeters as we have taken it. After finding it, you can find out the lambda. The lambda is given by the formula d sine theta n divided by n. After finding the lambda, we can get the mean value of lambda by adding all the values and dividing by 6. The same procedure we have to repeat for the distance f is equal to 80 centimeter, and we have to get the same values 2xn, xn and theta n. After finding all the things, we have to find the lambda value and the mean value for the lambda. After finding the mean value, we can add the 80 centimeter distance and the 100 centimeter distance lambda values, and we can divide by 2 and we can get the exact value of lambda. That's all.